Hi students, welcome to my lectures on thermodynamics. In the last class, we have discussed about the constant pressure process. From the constant pressure process, what is the work requirement and what is the sign convention? In today's lecture, we are going to discuss about the two more processes. One is constant volume process and second is PV equal to constant process. Okay, let us calculate the work requirements in these two processes. And the first one, we talk about the constant volume process, and the displacement work is nothing but minus integral PdV from V1 to V2. That means you can able to calculate the work using this formula. So imagine a piston and cylinder assembly is there, and I am taking the system from state 1 to state 2. State 1 is having P1 pressure, V1 pressure. State 2 is having P2 pressure and V2 pressure. So the name itself suggests that it's a constant volume process. In constant volume process, the volume will not change. Before and after, the volume will not change, only pressure will change. P1 and P2 are different because if I stop this piston and cylinder assembly using a stoppers, even though you supply heat, the expansion will not take place. Only what happens is the pressure inside the system may rise or may come down. Okay, that means I have stopped from both the, these are the stoppers, and I have stopped. From both the ways, it will not expand and it will not contract. And you can see the pressure is changing from P1 to P2. Okay, from state 1 to state 2, whereas the volume is not changing, volume remains here. That means initial volume is equal to final volume. In such cases, that V1 equal to V2 equal to V, which is constant. That is, if the volume, if expansion or contraction is not taking place, the displacement work is zero. Even the pressure is changing, if the volume is not changing, the displacement work is zero. That means V equal to constant means dV equal to 0. So if you apply the formula, if you want to calculate the displacement work is equal to minus integral V1 to V2, initial volume to final volume, P into dV. Here the dV itself is equal to 0. Okay, in such cases, in constant volume process, the work is also 0, the displacement work. For example, even though initial pressure example for the state 1, initial pressure is 1000 pascals and final pressure is 2000 pascals. Initial volume is 1 liter, final volume is also 1 liter. In such cases, even though pressure is changing, volume is not changing. In such cases, the displacement work equal to 0. So let us go to the another process which is called PV equal to constant. That means product of pressure into volume is constant. So let us have something on the board, the same piston and cylinder assembly. The state 1 is equal to P1, V1, state 2 is nothing but P2, V2. If you are bringing the system from state 1 to state 2 using the process called PV equal to constant process. What is the PV equal to constant means? At any point in this line, the product of P1 into V1 is the same, whereas P2 into V2 is the same. Both are same. That means P into V will not change. If P increases, V decreases. If V decreases, P increases, such that P into V remains the same. That is called PV equal to constant process. That means that means the P1 into V1, which is equal to P2 into V2. That means along this line, the PV will be the same. That is what is PV equal to constant process. Where exactly this constant process comes is, if you take the ideal gas law, if you have a PV is equal to nRT, pressure into volume is equal to number of moles into universal gas constant into temperature. If you make the temperature equal to constant, that means during this expansion and contractions of the cylinder, if you make the temperature remains constant in state 1 and state 2, if you don't allow the temperature to change, in such cases the temperature will be the constant. That means number of moles inside the cylinder will be constant, universal gas constant will be constant, and temperature in the cylinder will remain the constant. That is N into R into T. There are 3 constants. That means everything is a constant. That means PV is equal to constant. That means P1 V1 equal to constant, P2 Vt is also constant. This is called the constant volume process. So because P into V is a constant, P1 V1 equal to P2 V2, the initial state P1 V1, which is equal to the final state P2 V2, which is equal to P into V. So that is what the constant PV equal to constant process, which applies to the at constant temperature conditions. So let us take some derivation how to calculate the work during this constant PV equal to constant expansion. That is the initial condition, because the state 1 is P1 V1, state 2 that is expansion process P2 V2. So during this expansion, how much amount of work is expended in the process? Let us calculate. So I know displacement work is equal to minus integral P into dV. If you substitute this, if you take these two, so instead of P you have to substitute P1 V1 by V. Or you can do this way, anything is possible. I am taking these two terms, that is P1 V1 equal to P into V, therefore P equal to P1 V1 by V. Let us substitute in place of P that P1 V1 by V into dV. Because I know P1 V1 is constant, so anything that constant inside the integral, that will come out of the integral. So that is why displacement work is equal to minus P1 V1 into integral V1 to V2 1 by V dV. As you know, 1 by x dx, the integration of 1 by x dx is ln V from limits V1 to V2. So if you substitute, minus P1 V1 is equal to ln V2 minus ln V1. So that is nothing but minus P1 V1 into ln V2 by V1. This is the displacement work. That means if you know P1 V1 and V2, you can able to calculate how much how much of work is involved in this expansion process. So let us take the small example. So there is a cylinder that has expanded with this PV equal to constant process. Okay, that means you have to use this equation to calculate the work. Given initial pressure is 1000 pascals, initial volume is 1 meter cube, final volume is 2 meter cube. That means expanded to 2 meter cube. So calculate the work. Let us use this equation. If you substitute P1, 1000, V1 equal to 1, V2 is equal to 2, V1 equal to 1, you can calculate work done in displacement work is nothing but minus 693.14 joules. The minus has come. As you already discussed in the sign convention process, cylinder got expanded means the system has done work on the surroundings. If system has done work on the surroundings, the negative will come. Negative means it's an expansion process. If you do the other way, from maximum to minimum volume, it will become a contraction. Okay, compression process. In such cases, you will get a positive number. So let us do, in continuation to this example, now you know how much work has been done by bringing the system from state 1 to state 2. I know P1, V1 and V2. Then what is P2? I know the initial pressure, which is 1000 pascals. Then how can calculate what is the final pressure? Very simple. I have to use the same expression, P1 V1 equal to P2 V2. P1 V1 equal to P2 V2. From this P2 equal to P1 V1 by V2, which is equal to 1000 into 1 by 2, which is 500 pascals. That means initial pressure is 1000, final pressure is 500. Initial volume is 1 meter cube, final volume is 2 meter cube. So that is what. That means if the pressure is higher, volume is lower. If the pressure is lower, volume is the higher. That is what this expression tells. P1 V1 equal to P2 V2. So that is what P1 is equal to 1000, V1 equal to 1, P2 equal to 500, V2 equal to 2. The work done in this expansion process is minus. I hope now you have understood what is the constant volume process, and the another process is PV equal to constant process. So let us meet with the new lecture. Thank you very much.